Hi, this is Ratan Gupta from Knowledge Varsity. In this video session, we are going to understand how to compute beta when the stock prices and the index prices are given. Note that beta is a measure of systematic risk and it ignores the firm specific risk. Right? So let us understand what are the different methods to compute. First of all, we have to compute the returns. Note that the standard deviation or the covariance is not computed on the prices. Those are computed on the returns. So the data is, this is the date, this is the stock closing price and the index closing price. We'll take on the closing prices. Now there are two ways to get the return. We'll compute simple arithmetic return. So simple arithmetic return will be the final value minus the initial value divided by the initial value. So you can write this way: final price minus initial price divided by the initial price. So this is one way to compute the return. Or you can see in this what we are doing is B3 minus B2 divided by B2. So essentially you are dividing both this by B2. So you can say it is B3 by B2 minus 1. That also you can write. So it can be written as B3 divided by B2 minus 1. This will also work. I would suggest you to use this formula and then you can double click and it will get copied to all the other cells. For the daily index return, what you can do is you can drag this formula here, okay, and you can just check it is computing this by this, which is correct, and we will double click here. So I have got the daily returns for the stock and the index. Now using the stock prices and the index value, we have to compute the daily returns, we have to compute the index return, which we have done. Now using the returns computed, we have to compute the daily standard deviation of the stock's return. So daily standard deviation can be computed using standard dev function. Now there are two standard deviation function. One is stdev.p, stdev.s. .p means population, .s means sample. So if you think that this is a sample, you should use s, or you can use p if you think it's a population. As of now, I have used with respect to p, even though it will be a sample, but let's see, taking as a p, it doesn't make much difference here. So the daily standard deviation will be, we will select all the cells and it comes as 3.14% for the stock. And for the index it will be stdev.p and we select the first cell and select up till end and enter. So you can see that the standard deviation of the stock is higher than the index because index is collection of many stocks, so it is less volatile as compared to the individual stock. Then we have to compute the covariance between the stock return and the index return. Again we are saying it is a population, so covariance can be computed using Excel function covariance.p, and it needs two arrays. First array is for, let's say, stock, control shift down, comma. The second is for the daily index return, control shift down, and we'll press enter. So the covariance, please note that it comes as percentage. We should not think this as a percentage, but let's say we take it as a number, okay, because covariance is actually percentage square. So this is the covariance between the stock and the index return. Now with the covariance standard deviation, we need to compute the beta of the stock using covariance formula. Now how is beta computed using covariance formula? So the beta is given as covariance. So beta is given as covariance of the stock and the market, which is the index, divided by the variance of the index, which is the market. Or let's say covariance of, we'll say market, which is nothing but the index, and we say as the stock. So this is a formula, covariance of stock and market divided by variance of market. So if we do that, we'll say this is the covariance we have got divided by variance of the index. Now how do we get the variance of the index? Note that variance is standard deviation square. So we'll select this standard deviation and we will make it to the power 2. So in Excel, this upper arrow sign, caret sign is your square sign. So we will get this beta, but this is coming as percentage. We can make it to decimal number. Okay, so we can increase the decimal, so it comes as 1.498. So this is one way to compute the beta. Another way to compute the beta is using slope formula. So let's say we use slope. Now this slope is a function which does the linear regression. Now please note that in how do we compute beta? In beta, what we say is, on the y-axis we have the stock returns. Okay, on the x-axis we have the index return, and we plot these returns. Okay, plot these returns. There will be many returns, and then we come up with the best linear estimate, best linear line, which is resulting in least sum of square, and the slope is your beta. The slope is beta. So hence the function slope. So please note that the slope, it asks you what are the known y's and what are the known x. What is y? Y is the dependent variable, and x is your independent variable. In this case, the independent variable is the index or the market, and the dependent variable are the stock returns. So let's see, known y's, will first enter the y's, and then we will enter the x, and we get it. So let's see, we can format it. Yeah. So using the slope formula also we have got the beta. Right. The third method could be to do a plotting of this data using a scatter plot. So what you can do is, let's say you can insert a scatter plot. Okay, so we will change the data in the scatter plot. So select data, edit. So x values. So what are the x values? We have said that index returns are the x values. Okay, and y values we know are the stock, and we say okay. We say okay, and we can see that this is the plot that we have got. Okay, so this is the plot we have got, and the best fit line will be the regression line, which we have to compute. So what we'll do is we'll right click on this and we say add trend line, and then this we are doing the regression is linear regression, and we say display equation on chart and display R square, and close it, and you will see that this is the slope. We are saying that y, which is the stock return, is equal to 1.498 into the index return minus 0.017, and R square is 0.1184. That means with the coefficient of determination R square is 11%. Right? So we got three methods to compute beta. Thank you.